Whenever we are learning to find and exploit or prevent different types of vulnerabilities, we always want to understand its root causes and what actually happens to an application when the vulnerability is being exploited. So today, let's talk about a common vulnerability, the remote code execution vulnerability, its mechanisms, and how you can spot it in source code. Remote code execution vulnerabilities are also called RCEs. They're a class of vulnerabilities that happens when attackers can execute their code on your machine. And there are many different types of bugs that can lead to RCEs, like insecure deserialization, SQL injections, and so on. But a very common reason that leads to RCE is applications concatenating user input into executable code or system commands. And when the application cannot tell the difference between user input and the code that is supposed to be executed, it will execute malicious user input as code. And as a result, attackers can execute arbitrary code on your machine. And so before we go on, there are a few concepts that you should probably understand in order to conduct a source code review effectively. The concepts are sources, sinks, and data flow. In code analysis, a source is the code that allows a vulnerability to happen, whereas a sink is where a vulnerability actually happens. So take command injection vulnerabilities, for example. Command injection vulnerabilities are also a type of RCE vulnerabilities. A source in this case would be a function that takes in user input, whereas a sink would be functions that execute system commands. And if untrusted user input can get from the source to the sink without proper sanitization or validation, then there is a command injection vulnerability in that application. And many common vulnerabilities can actually be identified by tracking this data flow from appropriate sources to their corresponding sinks. So the vulnerability that we will be looking at today is RCE. And as I said, there are many different types of root causes for RCE, but for now, let's focus on command injection vulnerabilities, or vulnerabilities that happen when user input is being concatenated with commands or passed into dangerous functions as commands or as code. So we're going to fire up the analysis tool that we're going to be using today called Ocular real fast. And then import the project that we are analyzing. We will be analyzing a Java project called Target Java, and we will be feeding a WAR file into Ocular to be analyzed. And after I imported the project, I like to run a command to make sure that I have the project properly loaded. And I typically run the query cpg.method.name.l for this purpose. This command will look for all the methods defined in the project, extract their names, and then list them. So this is essentially a query that tells Ocular to list all the method names in the project. With Ocular, you can also list all the identifiers in the application instead. So this means things like local variables, globals, and class members. So now let's start by looking for the sources of a command injection vulnerability. We are looking for user input, right? So a good way to do that is to look for identifiers that are of the type HTTP servlet request. So we'll filter the identifier list by its type name. And with Ocular, you can actually do string searches with regex. So here we're essentially looking for identifiers whose type name contain the string HTTP servlet request. You can see here that this gives us a list of identifiers that contain input from HTTP requests. We'll define this as the source of our vulnerability. Next up, let's take a look at sink functions for command injections. We are going to look for dangerous functions that indicate code execution in the program. And there are a lot of different functions that could indicate the execution of code in the program. But for this demo, let's focus on calls to the method exec, which often indicates system command execution in many programming languages. Let's first determine if this program that we're analyzing is using exec anywhere. We will tell Ocular to find all the calls to exec and display that line of code, the file name that the call is in, and its line number. And you can see here that there are 3 calls to exec, all located in the file insider.java. We can define the sink of our vulnerability as all calls to exec. And then since we're tracing identifiers being passed into exec as arguments, we'll add .arguments here. And finally, we can tell Ocular, show me all the places where a source can reach a sink in terms of data flow, and print the results. You'll see a list of data flows where HTTP request data are being passed into exec as an argument.